This problem is all about implementing the sigmoid activation function. So the sigmoid activation function is often used in binary classification as the output on the output node of a neural network. And if we look at the sigmoid activation equation, it's 1 over 1 plus e to the negative x. What that gives us as output, or if we look at the graph of it, we see that it outputs a number between 0 and 1. So whatever input z we give, it's going to output some number between 0 or 1, which we can interpret as a probability. And it has this nice property that the number gets closer and closer to 1 as z increases, so that as you have very drastic values, it goes from like 0.98 to 0.99 rather than 0.6 to 0.8. So the jumps get less dramatic as it's more clear that you're under one class and not the other. So that's why we like using the sigmoid activation function. To implement this problem, we could simply return 1 over 1 plus e to the negative x, so 1 plus math.exponent of negative x. We're going to have to import math for that to work. So let's see if this passes the test cases. Moment of truth, and all test cases passed. So that is the sigmoid activation function.